All righty. Hello, everybody, and welcome to another episode of Taco Tuesday. Three of us are online right now. We do not have cameras, unfortunately. Something's going a little crazy today. So myself, Dave Holdorf, is here. I am also joined with John Barba and Rick Mayo, and you've got 100% of the residential training team online with us today. So,
how about that?
Yeah, I know. We're all around today. That's amazing. It's amazing. It's for all of us to be able to make our Taco Tuesday. Unfortunately, since I can't get the camera to work today, you wouldn't be able to see. I'm actually in one of the training rooms down here in Cranston, Rhode Island today, and you'd be able to see some of that training room behind me. But unfortunately, no cameras. So it might be a plus that you don't see me today. Or the other two of us. So anyhow, we are glad that you are here joining us for another wonderful Taco Tuesday. Greatly appreciate everybody stopping in. And today's class is making the most of a DHW delivery system. So without further ado, let's get started with that. So if this is your first time joining a go-to webinar, what I want you to do is pay attention to the control panel. And the control panel, if you do not see the control panel like you see here on the screen, what I want you to do is click on that orange arrow and make sure the arrow points to the right. And when you click, if it is pointing to the left, click on it and point it to the right. You're going to see what you see here on the screen. And then therefore you can go through and check your audio section, make sure that one, you can hear us. If we have any handouts, which we do not have any handouts for today, and if there are any questions and communication, this is how you're going to talk to us. Everybody's microphone is muted. I know we had around 200 of you joining us today. So you'll find that questions chat section area. It may look like a question mark on your end, depending on what device you're using. But if I can ask everybody real quick, just to make sure everything is working wonderful, a quick hi, hello, how are you would be wonderful to make sure that the communication is working that way. So if I ask a question, this is how you're going to get into us. If you want to answer a question, that's how you'll answer the question. So excellent. I do see some coming in. Wanted to make sure everything is working fine. So Wayne Barton and Frank Falter, thank you very much. Peter Gagnon, Travis, good to see you, Travis and Travis. Two Travises there. So glad everything is working. And periodically we will ask questions just to make sure that we are still communicating and we didn't drop our connection. There have been times that we have spoken to ourselves for about 15 minutes until I got a text message saying, you dumped out, Dave. So excellent. Thank you so much for responding to that. Now, if you are using GoToWebinar on a device, on your phone or a tablet, things will look a little bit different. And the way you maneuver the screens is through the bottom of the screen. And the first icon you'll see is the screen. You'll have to toggle between the webcams and the presentation, but you don't have to worry about any webcams today. We don't have any up, so you're good there. But if you want to ask any questions, you'll have to scroll down to the end. You'll got your audio section, make sure you can hear, but you have to toggle in between everything in order to communicate with us. So that's that. The next thing out there, if you guys are out on social media, take a look at us. On Instagram, all right, you'll see Taco Comfort. Myself is Taco Training, and John is J Barber Taco Trainer. We are also company-wide all over LinkedIn and YouTube and Facebook. So go hook us up out there. I put up a couple of QR codes, so if you're not already following us on the YouTube or the Facebook page, you can scan those and find our links rather quickly. So look forward to seeing you all out there. And we've got a lot of people doing a lot of work on our social media pages. So let's talk about getting hot water. All right. And the last couple of weeks in the residential side, we've been talking about domestic hot water recirculation. 2 weeks ago, John went through designing and circulator selection and using our app in order to do that. A couple of weeks ago, I had gone through the different types of ways to add a hot water recirculation system to a home. So the first thing I want to start talking about today is controlling that circulator. So if you have a domestic hot water recirculation system installed, whether in your home or even some small light commercial applications, how do you control it? How are the different ways that we control domestic hot water recirculation? I'd love to see some comments come through on how you are designing and installing your hot water recirc systems out there. There's a lot of different ways, and every one is just as good as the other. It will depend upon your applications, obviously, but first off, and I know probably the absolute easiest way to control a domestic hot water recirculation is just to plug it in. Just give it power 24 hours a day, 7 days a week. That is probably the most easiest way, and done quite often. And depending upon the application, may need to be done that way. For example, like a hotel or an apartment building where domestic use patterns are all over the place. So that's one way. Now, if we are concerned about electrical consumption and trying to keep that power load down low, the second way is to go ahead and add an aquastat. So which means on that dedicated return line that we have run back from that furthest point in the house, we'll put an aquastat on it. And if the water temperature gets warm on that return pipe, that means all of the supply pipe beforehand has been warmed up already, and therefore shut the circulator off. The need of the circulator running isn't there any longer. So we'll shut it down. So not a bad way to do it. Unfortunately, the downsides is to where the sensor gets placed, where your aquastat gets placed. And typically we put it, a lot of times it ends up getting installed at the water heater after the entire return line run. Okay, not bad, but we've also now got the entire return pipe hot. We don't need the return pipe warmed up. We just need hot water at the furthest fixture, and that's the best place to get it. It's not always the easiest option to do. So not a horrible way to go. I saw a couple of answers come through where we put a timer on it. All right, timers are excellent. Yes, most people use water on a regular schedule, meaning when do I need my hot water? I need a couple hours in the morning for showers. I need a couple hours in the evening when I come home from work to do the laundry, get the kids bathed up and whatnot. So putting a timer on it is not bad. And here you could see a couple different ways to do it. We have a standard 24-hour day timer, and each one of those pins that you see here on the analog side, it represents 15 minutes of runtime of the circulator itself. So if you take a shower at 7 a.m. every day, turn it on a little before and turn it on for a little bit afterwards. The digital timer on the right-hand side is now giving you a 7-day calendar. So now you have flexibility instead of every day the same schedule, because, hey, the weekends come along and we might need to change some things up. So you've got your options to control your circulator. The next option for controlling your circulator is a combination of the timer and the aquastat, okay? So now you can do an aquastat in conjunction with the timer to keep the circulator off more than on, all right? That's the idea. We want to keep that circulator off as long as we can, but also make sure that the water's warm, and also when do we need it to be running. So you can do a combination of the two. But I think we can get better. All right, with today's technology that's out there, there are ways to get these things controlled a heck of a lot better out there. And now we can actually start learning when people use hot water in a home. So for example, obviously this is not controlling a circulator, but this is one of the most popular thermostats available out there. A lot of homeowners love this style of thermostat. And why? Why do you think people want to have this type of thermostat in there? Now, I know I run into a lot of installers out there. They have challenges with this thermostat, especially hooking up to older style systems, heating systems. But why do homeowners want to see this thermostat? Why are they so clamoring to get one of these installed in their home? And I bet the first answers are going to pop in there. And I'm not monitoring many of the questions. John and Rick are monitoring those today. So I do greatly appreciate anybody typing stuff in there. But a lot of people always assume as soon as we get a Nest thermostat, the biggest reason is because I could see it from my phone. There we go. Francisco dropped it in there. Yeah, that's the biggest assumption. And for the first 2 to 3 months that you have one of these, people say they're always looking at it. After that, maybe once a year. And I've seen some of the data coming from some of these thermostats that are out there on when people log in and people use it. And it's not as much as we think. Not as much as we think. I've got a couple of them in my home that I've used for The biggest reason, because it programs itself. All right. Yeah, Scott, there you go. Scott says it programs itself out there because it's got that motion sensor. How many people here that are online with us today have a programmable thermostat installed in their home? Not programmed, right? Because it's a pain in the neck, right? And then the batteries go dead on you, and then you got to go ahead and do it again. So putting a Nest thermostat learns and then adjusts the schedule for you when you are at different times, right? So, so it's interesting when we start thinking about that. So we took that learning technology, not necessarily with a motion sensor, and applied it to a domestic hot water recirculation style system. And we call it the smart plug. The smart plug learns when people use hot water in their home and will run the circulator for those time periods. Okay, so now, and it's always thirsty for knowledge and will always adjust your schedule as you are using hot water in your home. So now we have a smart system out there. It doesn't have an app, doesn't need to have an app out there. We just wanted to run the hot water circulation system. Okay, so we look at the smart plug. It is a very basic device. It plugs into the wall. You plug the circulator into that. Off the bottom, there is a temperature sensor that we put on the hot water supply that's feeding out of the water heater, and it's going to learn when people use hot water in the house. So you could take any standard corded circulator and make it a smart circulator. And we won the AHR Innovation Award a few years ago. Yeah, it's already going back about 5 years ago. I'm still pretty proud of this this little device in winning the Product of the Entire Year award at the AHR show. So it's a very simple setup in what you've got going on. For example, your timer, not a bad way to go. However, does have a couple of faults. All right, one, we have power outages. You have a power outage, the clock itself is stuck where the power went out. When the power comes back on again, then you end up with the timer being set for the wrong time of the day for when it turns on. So that becomes a challenge. And two, it happens twice a year, depending on where you are, we end up with daylight savings, and that's going to throw up your schedule. So, and for those homeowners that maybe didn't know on how easy it was to program, when you have that power outage, now all of a sudden we assume there's something wrong with the system. We don't have hot water in the morning. Customer gets called, comes out to the job site, takes a look at it and says, oh, your clock was adjusted wrong, and turns the clock and makes that adjustment real fast and easy. So we want to use something that's going to learn when people use hot water and adjust itself over time, especially when you say have power outages or daylight savings comes along. It's going to change things for you. So what this does is that it learns events. It's not looking for actual temperature. It's looking for an event. And an event in water usage is a temperature rise in the pipe itself, or duration at that temperature, and then a temperature fall. And it records that as an event and says, okay, 5 o'clock on Sunday, 5 o'clock on Sunday, hot water was used. The following Sunday, I'm going to make sure my circulator turns on a little bit before that 5 o'clock and a little bit after that 5 o'clock to give you that window of opportunity to get into the shower itself and run the circulator for those time periods. So when you first install the smart plug, what it does is it runs for 5 minutes on, 10 minutes off for the first 7 days, looking for those events. So that first 7 days, there's always going to be the availability of hot water at every fixture. But now it's looking for the duration, looking for those events to record. And then after that first 7 days, it drops back to the schedule and does that little bit before the event, that little bit after the event to ensure you've got hot water when you want it. So for example, what's it do? So let's say we take a look at an 18-hour slice of day. And on Monday and Tuesday, you have very specific water usage patterns. And there was a shower taken at 7 a.m. All right, so 7 a.m. was recorded. And so it's going to come on a little bit before. The circulator will stay on for a little bit afterwards. Now, during that on period that you see here, all right, when that circulator is on, so what I'm imagining right now is the red line is on for the circulator, all right, and the white line is off for the circulator. So when it is on, that means it's activated, not necessarily running the entire time. What it's doing is running here, 5 minutes on, 10 minutes off. The water's not going to cool down that fast in the pipe, so that's okay. So, but at least it's making sure the pipe is charged with that warm water so it doesn't cool down. So it learned that one event on Monday and Tuesday, it shuts off, and so then it coasts down to the rest of the day. Now on Monday and Tuesday, somebody's home, some laundry was done, all right, around 1 o'clock, again, a little bit before, a little bit after the circulator runs, then it shuts down, and then in the evenings, we've got baths for the kids, all right, a little bit longer. Maybe there were 2 events, back-to-back baths for 2 different kids, so it stays on a little bit longer, and then it shuts off, and then it stays off the rest of the night until the next day. Smart plug has a 7-day calendar built into it. So let's say on Wednesday, there is nobody home doing laundry in the middle of the day. And so therefore that event is not recorded. So now we're looking at a very, very small amount of runtime, actual power consumption of the circulator itself that's going to run your DHW recirc system. So excellent, excellent. JB and Rick, are there any questions out there that I need to convey to everybody?
Nothing that I'm jumping out at me anyway.
Yep, I'd agree with that. Not at this time.
Excellent, excellent. So either 1, I'm doing a horrible job, or 2, I'm doing a really good job.
I'd go with the latter if I were you.
All right. Sounds good. Sounds good. So that is how we're what the smart plug is doing. It's always going to be thirsty for knowledge. So let's say there was a Wednesday where there were no baths. It would actually, the following Wednesday, would actually turn it off. So it knows that nobody had used it that week. So it's always going to change the schedule based upon what's going on. Now, if you don't have any schedules in your home, water usage is all over the place. For example, like the last couple of years, we got stuck at home and we weren't working in an office and taking showers every day at 7 a.m. You might have said, oh, you know what? Today's a good day to get that shower in around 11 o'clock in the morning. You can take the smart plug. There's a button on the bottom and you can change it to the pulse mode. And what the pulse mode will do is run 5 on, 10 off all day, all night, all right, for the entire week. So because there is no schedules. So that's where you would use it in that apartment building application where people are always home or always in and out, or so let's say a hotel, all right. You never know when the usage patterns are going to be in a hotel area. So you have that hot water circ pump, not necessarily 24 hours a day, all right, 5 on, 10 off. Cut that power load way down low with the smart plug. So the smart plug is not necessarily for a small residential circulator. We could do up to a 6 amp load on there. So we can control larger circulators with it. All right. Now that we have plenty of hot water, do we have enough? I'm going to move along to our delivery system here. After controlling the hot water recirculation, now I want to talk about having enough hot water. And I think this is a situation that runs into a lot of homes where people don't have enough hot water in it. They run out. The water cools down. And what do they end up doing about it? Usually nothing. We just say, yep, we ran out of hot water. So you can't do those back-to-back showers. And you just learn to grow with it and live with it in your home. And it doesn't have to be. There are ways that we can make this thing a little bit better. And one of those things is thinking about adding in mixing valves. Now, when people start thinking about mixing valves installed in a residential domestic hot water system, we think of mixing valves for a couple of reasons other than getting me more hot water. Biggest reason is to prevent scalding, to really control your water temperature in the house itself. So that's one of the biggest things. And we see this a lot of times code-wise, that we need to install mixing valves in our house because of code and making sure we're controlled the right amount of temperature going out. But when we think about scalding issues, you know, there 6,000 injuries can occur from domestic hot water. And we know, let's say we're keeping our water heater at 115 or 120 degrees. That thermostat that's in the water heater is down towards the bottom sometimes, in that the bottom third, and the water's going to stack and get hotter. So we can see some hotter water coming out of the fixtures throughout the house. So a lot of information about water heaters are out there. You can do some research on this and find more, right? But we can easily see 150, 155 degrees at the top of the water heater. All right, so preventing scalding is one reason for putting in mixing valves. All right, when we see some information about that, on how fast you can get scalded, for example, when we start looking at children are especially susceptible to it, at 140 degrees, it takes 5 seconds to get a second-degree burn for a child. All right, at 140 degrees. All right, 154 degrees. All right, we're getting, everybody's going to get a second-degree burn at 1 second. So it happens rather quickly, that people can get hurt from that hot water coming out of that top of the water heater itself. Another reason to consider mixing valves in your system is to prevent Legionella. All right, Legionella protection. And in order to get rid of the Legionella bacteria, all right, we can heat up that water, all right, periodically, or keep it a lot hotter in the tank itself to help kill that Legionella. All right, but if it's too hot, now we have that issue of scalding again. All right, so those are other reasons to think about adding mixing valves into your systems. However, that's not what I'm talking about today. I want to add, how do we get more boost? How do we get more more hot water? And the mixing valve can be our savior here, so to speak. All right. By adding a mixing valve into our system, we can get a perceived larger capacity out of the system rather than running out of hot water. And what you see here is a picture of one of our oldest products that we have. We helped develop the mixing valve back in the early 20s after our side-on water heaters. So, and this also is one of those points in time where the original name of the company back in 1920 of the Thermal Appliance Company got shortened to T.A.CO, because we just couldn't put Thermal Appliance Company on the sides of that mixing valve. So the tempering valve is going to help us make that tank seem bigger. And there is a formula that is available to do that. So what you see here, this formula is a storage factor that we will apply to the usable capacity of a water heater to get us more output of that tank itself. And what you see here is T mix is our mixed water temperature that we're sending out to the fixtures in the house, minus the temperature of the incoming water from the street, all right, or from your well, and we divide that by the T stored, which is what we have in our tank itself, whether it's a water heater or an indirect tank, minus the incoming temperature from the street. That gets us our storage factor, which we will then apply to our usable capacity of the tank. So let's create that capacity. Let's take a look and use this formula, how you would use it. So for example, we have 112-degree delivery going out to our house. We have 50 degrees coming in from the street or your well. We're going to store at 140 degrees in our tank, minus the 50 degrees coming in from the street. And we take that number, we math that out. We got 62 divided by 90, which gets us a 0.69 storage factor. Now we want to apply that, like I said, to the usable capacity of our tank. And if you have a 45-gallon tank, you do not have 45 gallons available. What you have is around 70–75% available, because you, in a standard tank type water heater, right down the middle of it, you've got your flue pipe. All right, if you're looking at a fuel fired water heater, so you've got the flue right there. If you're looking at an indirect, we have a coil. All right, that's also going to take up some volume of water. And then of course, as soon as you start drawing off of it, we start introducing 50-degree water back into that tank. So therefore, we only have around a 70–75% capacity. So if we're using my example here as a 45-gallon tank, we're looking at about 34 gallons of usable water to use. So take that usable capacity, divide it by the storage factor, and we have a tempered capacity. So 34 gallons divided by 0.69 gets us to just under 50 gallons of available hot water for the house, compared to 34 gallons by the simple addition of adding a mixing valve. So if you run out of hot water in your home, there are things you can do, like put in bigger water heaters. All right, well, that's a large expense. All right, or putting in a bigger boiler if you're using an indirect tank in order to drive the capacity of that tank to its maximum capabilities. Those two options obviously very high dollars, large expense, and even sometimes putting in a larger water heater doesn't work if your home only has enough space for that water heater that fit in there. I remember quite a few years ago when there was some NECA standards that came out in creating the efficiencies of water heaters, which means the insulation jacket got larger, and some homes that had a 40-gallon water heater that was shoehorned into this closet space, you were not fitting that same 40 in there. You had to put a 30 in instead. Now all of a sudden we started running low. Mixing valves can help on that respect. So that's one thing that you can do, is to add more capacity with adding a mixing valve in there. So, little story in my own home. My house was a family of 4, and we grew to a family of 6. No, we didn't have twins. We put an apartment on the house, and my in-laws moved in. So now we went to a family of 6. And if I had 6 people in the home, everybody told me I needed to have at least an 80-gallon water heater in my home in order to satisfy that load. What I did was, I had a mixing valve on my system. I had a small 40-gallon tank, all right, and basically set up like this at the 140, 112. Actually, I'm sorry, before I finish that story, nobody questioned. I don't think anybody questioned it just yet, but I'm sure quite a few of you out there looked at the 112-degree delivery. And why did I use 112 instead of, say, 120, which a lot of systems are sent out to, or 115? The reason why I chose the 112 for this formula is because of the storage temperature set at 140 degrees for my tank. A lot of mixing valves out there, and you got to pay attention to the valve that you're using in the project. You need to see a 27-degree spread between the delivered temperature and the stored temperature, so you get the thermostatic element of the valve to operate properly. When the spread gets too small, too close, you won't get that full operation of the valve. And what we have found out there is that you get a little sandwiching of the water temperature being delivered to your fixtures, meaning it's warm, then cool, then warm, then cool, then warm, then cool. You feel a little bit of sandwiching because the valve doesn't have that full opening and trying to control that water temperature. It's always trying to be on the safe side so it doesn't send too hot of a water out, but then it starts to close down on itself. So you want to see a nice spread between. There are also valves out there, and we have them also, that are a 10-degree spread. So just pay attention to what the delta T of the mixing valve being used in the application, that you have your stored temperature and your delivery temperature either 10 or at least 27 or more. You can do it further. You can easily do it further. You can change that temperature from that 140 to something higher. And that's what I did in my home. As I was talking of that story before, because I wanted to remember this 27 degrees, what I did in my house now, because I had my mixing valve in there, I increased the capacity and pushed, so to speak, the envelope. So instead of, I have an indirect tank in my home, so I was able to raise the water temperature stored at my home. And what I did is I stored at 160 degrees. So by storing at 160, and let's keep the 112-degree delivery, that's fine. As I do that math and I get a 0.56 storage factor, I then turn around and now I have the usable capacity of a 60-gallon tank, or buying it or installing the amount that would be in an 80-gallon tank that I originally would need. Now, if I put an 80-gallon tank in my boiler room is a 6-foot closet. I have 8 zones of radiant in my house. So I have stuff if I've dropped in an 80-gallon tank into my mechanical room, I have stuff on the wall on the back of my mechanical room that I'd never see again, meaning like manifolds and actuators and controls. I'd have to remove the tank in order to access any of that area. So by keeping the smaller tank in my home and increasing the water temperature going out, allowed me to not have to change any major equipment in my home in order to satisfy my heating demands. All right, any questions out there? So a couple comments come in, I believe. Or questions?
Dave, one was just life expectancy. If we run the heater hotter, could we see a diminished life? And I've not seen anything to support that, but I can see why Travis is leaning that direction. Again, we'd have to just check with the manufacturer. I think as long as you stayed within their tolerances for set point temperatures, you still get the warranty from the manufacturer. And John brings up a good point. Go ahead, John. You're talking about accumulation and
Yeah, there are a lot of
scale.
factors
Yeah.
that play into water heater life, the end of a water heater's life. Gas water heaters, a lot of it has to do with sediment building up at the bottom, and that the water
Yeah.
heater's never really flushed out, and that stuff's never really drained out. So that creates a barrier between the water and the flame, and that heat builds up there, and that's what causes failures down at the bottom for gas water heaters. And a lot of people never really service the anode rod. The water heaters are considered throwaway items anyway, so they don't service the anode rod. You replace the anode rod and flush out a water heater. A gas water heater can, and even electric water heater, they can last an awful long time.
Sure.
So those are some things to think about.
Yes, and yeah, always pay attention to the specs from the manufacturer on that. Yes, I think if you start exceeding, and depends upon the brand, once you start getting, say, over 155, over 160 degrees stored in a standard type water heater, they consider that a commercial or industrial water heater itself, and your warranties on those are a lot less than, say, a residential at 7 to 10 years. So that is some changes that happens, and they don't like to see water heaters running that hot typically. In my example, I have an indirect tank in my house, so I can go a little bit warmer. So if you got an indirect, you can go warmer definitely all day long. All right, but just do pay attention to your standard water heaters and getting them too hot. Excellent. Thank you. Great questions out there. Keep them coming, people. Greatly appreciate it as we continue along. So I hope this makes sense to you. It's interesting because the second story after my in-laws moved in is what I started with. People just live with not having enough hot water or not being able to deliver enough hot water out to the home. So when my in-laws moved in, my mother-in-law would stop into my house every couple of days or so and make an announcement. And the announcement was for everybody in the house saying she was doing laundry. And what is that code for when you hear that? When you hear somebody yell out in the house, "I'm doing the laundry," all right, that was code for everybody else in the entire house to not take a shower. So, and I thought it was kind of odd because, of course, this is the first time living with my in-laws. Why she always had to make that announcement, I wasn't sure. Did she just want the credit that she was doing laundry? I don't know. So I went over there one day after this 3 months time, and I do spend a lot of time on the road. And I said, I never come over to you, or we don't come to your house and tell you when we're doing laundry. And she's like, "Yeah, I just thought you were being inconsiderate." I'm like, no, that's not the point. It was, when I designed the system here in the house, I designed it to make sure that we had more than enough hot water available to everybody in the house. So I'm not just being inconsiderate. It was just, that's the way we designed it. You don't have to worry about that. She had lived with that in her old home, all right, for 40 years. All right, they had a small 30-gallon water heater, and the laundry just takes a huge dump of that water. And she loved having the oldest style machines. I think her old washing machine was probably 30 years old by the time they swapped it out. And the new one that she got, they didn't want any of that sensing and water savings feature. No, I want this thing filled to the top every single time I'm washing 2 shirts. So I said, and so that's, these are the things that we experienced in the home.
Hey, Dave.
Yes, sir.
One thing that comes to mind, you're talking about the volume of hot water. One of the things your mother-in-law might have been experiencing is that whole pressure change, right? So the way the solenoids work on washing machines, might just drastically reduce the pressure on one side or another. And that's, she might have been experiencing temperature fluctuations because of that. Not really running out of hot water, but just the pressure changes might have been part of that.
That too. That too. Well, the laundry was always the closest, right? So that took the immediate need, the path of least resistance, compared to the shower that was upstairs on the second floor furthest away. So yeah, totally, right? But it was always the way it was. And I said, and now that I replumbed it, I gutted the house and replumbed it and thought about how to do everything in the house properly so we wouldn't ever experience that. You know, the worst experience is anybody in the shower and the toilet gets flushed. I made sure that wasn't an issue either in my home, you know. You know, so it was just those, it's things about domestic hot water, you know, what are expectations of homeowners when it comes to domestic hot water in your home? Are they high or low? And typically relatively low when you think about an expectation. Your expectation is hot on the left and cold on the right. Yes, I want it to be leak free and I want to have it when I got it and stuff like that. But when there are problems with it, a lot of people just live with it. Okay, when they don't have enough of it or they have to wait for it, right? As we talked about with domestic recirc, you know, waiting for hot water has become almost a norm. Running out of hot water in your home, if you experience it, you just live with it and you don't know there's anything that can be done about it. So to a lot of my installers and service people that are online with us today, if this is simple, this is a conversation to have with any customer. Do you ever wait for hot water? Do you run out of hot water? There are solutions that we can do to help you eliminate that. Now, we don't know our customers' pain points on what they would be willing to install in their home to eliminate an inconvenience of waiting for hot water or running out of hot water. Just bring it up to them and let them know. Let them know that there are solutions. Most people do not know there are solutions to some of their problems they have with domestic hot water in their homes. It's very interesting. Yes, sir.
Nagesh has got a question and just says, are the tankless water heaters controlled the same way? I would say no, but you want to speak to that? I mean, I think where he's going is, you know, the aquastat setting, they do have a temperature setting on them, but you typically don't use mixing valves with tankless heaters. So anyway, whatever you think, but you want to speak.
So yeah, when we're talking today with our mixing valves, we are talking tank style where you have that stored temperature. When you start looking at your tankless, you're going to size your tankless based upon the need of the house, because it has very little stored hot water in there. So, and they do have their own temperature settings on there. So you're not going to get a tankless to give you more. All right, you put in a small tankless in your house and you don't have enough of it. Like if you can't run 2 showers at the same time, adding a mixing valve will not be able to let you do that because you just don't have the capacity on the heat exchanger itself. So you'd have to add storage, or you'd have to put in a bigger a tankless water heater. All right, I hope that answers your answer. I hope that answers your question. Sorry, and made sense. It makes sense, Rick?
Yeah.
Okay.
Another one.
Okay.
Nicholas is wanting some pictures, and what I'll do is I've got that little 11-page colored, detail, and we can put that. Can we put it on handouts, or I'll just ask him for his email and I'll send it to him.
Okay. All right. Well,
So
now
Nicholas,
of course
we'll
everybody
send that.
now everybody's here is going to want it too. So I do not have access to the handouts to add that myself, unfortunately.
You know, we can add it to the follow-up email, a link.
Okay.
But if you put it on somewhere, we can add a link to it.
Excellent.
All right, put it on on Google Docs or something, Rick, and then we can just include a link to it.
All
right, so
I'll get it to you somehow or another. So.
Okay.
All right.
Yeah. Send me the link and I can put it in.
Excellent. So let me just show real quick. I mean, when you take a look at this mixing valve right now that I have on the screen, coming out, heading up towards the top of the screen, that is going to your mix temperature. That's going out to your fixtures. All right. On the left-hand side, maybe on this valve, I can't tell. I can't see the lettering. Would be hot from the water heater itself. And then on the right-hand side would be your cold water supply. All right. So that's your cold water that is actually supplying the water heater will have a T in it and feed into this mixing valve. So if the water heater was 160 degrees and the water coming from the street is 50 degrees, the two will blend to get you that 112 going out to the house itself. So that's what you see here. I'm going to go back a slide and show you the mixing valve here on the right-hand side. The one on the right-hand side is our direct water heater mount. So which means right here at the bottom would be directly mounted to the water heater, which would see the 160. The left-hand side, this threaded portion, now would be my cold water supply coming in. And because this is sitting right on top of your tank, this valve actually comes as a kit. the kit is included a T to put onto the cold water side and a corrugated stainless hose or corrugated tube to tie into here would be your cold water supply. And then off the top is now going to be your mixed water temperature feeding all your fixtures. On the right-hand side of the water heater mount, the top port here is an adjustment of that water temperature if you wanted to change it. And the bottom port here is actually how we add hot water recirc. So if you had a recirculation system, as we talked about the last couple of weeks, that would tie in right to this bottom port here. We also offer them with mixing the mixing valves can get a thermometer. So if you are changing the temperature, you can see what's being delivered out to the house itself. And depending upon the valve that you're using, the cap is the tool to do the adjustment. You don't just turn the cap, it doesn't do anything. You actually pop the cap off. If you have a valve that has a triangle shape indented into the top, you take the cap off, turn it over, and you can do the adjustment of the valve. We also have other valves that are fixed temperature because you're not allowed. They are set and fixed for 120 degrees by code. Those standards are saying it's non-adjustable, can't increase the water temperature itself. So they're, like I said, different valves out there for different applications and where you are across the country itself. Excellent. Thank you for all the questions coming in. All right, let's move along. All right, let's jump out of mixing valves. And the last part of domestic hot water, or not even just domestic hot water, just water in general in our homes, is thinking about that water heater. All right, for example, flooding our homes. All right, and these are just statistics out there. I hate using scare tactics out there, but we know this information is out there for most of us out there, right? 5 million water heaters will fail every year, and the average lifespan of a water heater today is 7 to 10 years. All right. Now, a failure of that water heater just might mean, hey, I'm not making any more water. Another failure part might be it might have a hole in the side and we start leaking water out into the house itself. So this becomes a concern. So a little bit more information about water damage in a home. The average homeowner can spend up to $5,000 in flood damages outside of your insurance. Now, what denotes a flood damage in a home? Well, 8% is due to weather, right? There's nothing we can do about that, all right? That's a heavy rainstorm. That's the river overflowing that we see so many times in different parts of the country. Nothing that we can do to prevent that from the domestic hot water delivery system or just the water delivery system in our homes, all right? But we do see 30% to appliance failure, all right? And that is the water heater leaking or the washer machine leaking in the home or the dishwasher. So we can see those problems in our home. And then another 62%, the rest of it is in plumbing failure, a pipe burst. A lot of times we see the washer machine hoses. They should be replaced every 5 years. We see those hoses burst. We see a pipe freeze and then start leaking. There's all leaks that we can see in our home. So we have a lot of issues and scary stuff too in letting the water fail. And what's interesting about that, if anybody does experience the appliance failure or a pipe failure in their homes, what do you do about it? Stop and I know what we all supposed to do, right? You find the main shutoff valve. You know, where's the main shutoff valve in your home? And for example, some homes have them outside. All right. Some of them might be inside, but all of a sudden you look inside that closet and it's a little scary to a homeowner. How many homeowners out there know where the main shutoff is in their home nowadays? Unfortunately, we don't have this big sign installed in our homes. We should, all right, says water valve shutoff right here, right? A lot of people do not know any longer. People know less and less about their homes nowadays. So if there was a pipe failure or an appliance failure in the home, there's a big scramble trying to find where the main shutoff valve is, all right? And it's scary. And as water's coming out and you got nothing to do with it. I mean, matter of fact, this morning, it was very interesting. I was in a hotel. I was in the gym. All right. And I didn't get to talk to you about it, John. You probably didn't turn around and you saw it later because you were working out too. That all of a sudden there was a big pile of water all over the floor. And the hotel was actually doing some work on there and they were going to shut the water off earlier today. But all of a sudden, water just pouring out of this pipe that wasn't connected to anything. all over the floor. And I stood there for a second like, oh my God, what do I do? So I just went and grabbed the garbage pail and dropped it underneath there. But it was like that panic for a second. Why is there water dripping out of the ceiling? So
that's why that was there. I was
that's
fully
why that was there.
I was fully
Yeah.
involved in my workout going through the canyons of Utah.
Okay. So yes, that's what happened. I was working out right next to it, and all of a sudden the water started pouring on the floor. Everybody that was on the treadmills looking out the window didn't even know what was going on behind them, because everybody had headsets in. So yeah. So I see an answer from William. He was saying he knows where his valve is because he's the one who put it in. Excellent. Yeah, right. Most people have no idea. So all right. So what can we do about it? All right. So we actually have developed some products out there to help with that. And we call it the leak breaker. And we have another version, leak breaker with E-Link. And we'll talk about the two of those. And these are designed to work at the water heater. It is a shutoff valve with a sensor and a controller to automatically open and close that valve, or close the valve when it senses a leak. All right. Very simple operation, very simple device. We're not doing flow monitoring. That's a totally different device and totally different world. This is looking at leak detection as a basic ball valve controller and a sensor. And when that sensor gets wet, the circuit is completed. All right. So as you can see here, these circuits that are printed on this board here, as long as it can make a contact going across there, there is water, and this valve instantly closes within about 3 to 4 seconds. All right. You get an audible alarm. All right, and a flashing light on here telling you that the sensor has been tripped and the valve has been shut off. And then you can take a look at the valve manually, and you can see the knob on the top saying, oh, it's in the closed position. All right, so here we see it installed on a water heater. So if you're putting in a new water heater, very simple. All right, you just screw it right onto the cold water supply feeding into it, and then bring your cold water supply in behind that. We run the controller, install it on the wall, run the sensor, drop it on the floor underneath the water heater, and you're protected. So if you've ever had a water heater failure where it leaked in your home, all right, and you're putting in a new water heater in, this is an easy peasy installation happening right then and there. You're done. All right, doesn't take any extra work to install. And now you have that peace of mind of that water heater. How many times do we go down to the basement to inspect our water heaters nowadays too? People don't go down there, or they don't go to that corner. Oh, that's the scary corner, right? You know, always comes up to, I always think of that movie, Christmas Story, right? The boiler room, you know, it was the scary corner of the house. You never went there, the furnace room. So, you know, people stay away from it. Don't know what's going on down there. So what does the leak breaker look like? So we have a 3/4 inch full port ball valve with a CV of 27, all right? Meaning a very high CV value, very high flow rate, very low pressure drop going through that valve. It does come with the sensor itself with a 10-foot wire to the controller. And this controller is also powered. So we do need to get an outlet nearby, give it some power, but it also has 4 AA batteries. As one, you can run it on those 4 AA batteries. You don't necessarily have to have the power cord, or use the 4 AA batteries as backup if there was ever a power outage. So, so when you start thinking about where you're going to put the controller, and to the proximity of an outlet, you've got 8 feet to play with there. So the power cord does have 8 feet on there. The sensor, like I said, already has 10 feet of wire on there, but you can extend them. You can extend that wire if you want to. If you're going to the water heater right below, you don't need more than what's there. But we can also go ahead and start adding multiple sensors. And you might start thinking, well, why would I need multiple sensors on a water heater? Well, yes, this is designed, original design was for a water heater shutoff valve, but we can also use this as a main whole house shutoff. So as your cold water supply coming in from the street or from your well, you can drop this valve in first. Now we can run multiple sensors. So we can put one sensor at the water heater. We put one sensor next to the laundry room, all right, next to the washing machine. We can go ahead and put another one up by the dishwasher in the house, and you run those wires in series. So you can do now up to 10 sensors on one system. So we just, this as a kit is how you see it now. You can add the sensors as you go along, and you can use regular 18-2 thermostat wire up to 200 feet away from the controller. All right, and you go ahead with your sensors in series on the terminal block that we have on there. And I'll show you the next slide in regard to that. Before we go any further, we have any questions out there?
Yeah, there's one, can the leak breaker be programmed to exercise the valve occasionally to ensure it will actually close when needed? And of course, the correct answer is it already does that. Yes. It doesn't need to be programmed. It is programmed for that. So we got you covered there, Jesus.
Yep, what that does is it will, excellent question, thank you for that. So yes, it will cycle itself 2 weeks from the day it was installed, the day and time. All right, so, and it just starts to cycle itself. It doesn't go to a complete 100% close, it goes almost. So if you happen to be taking a shower at that moment, you might notice a small fluctuation in the pressure, and then it goes back to that full open again. So yes, we do that every 2 weeks, if I remember correctly.
And another question from Laura Winkler, does a plumber need to install the leak breaker, or is it easy for a homeowner? As with all of our products, we recommend professional installation. Yeah, our products are designed for the professional to install. We try to make it as comfortable and as easy as possible for the installer to put it in quickly and easily, but we absolutely support qualified professional plumbers to install any of our products.
That's correct. Excellent. All right, so here we can see the sensor, all right, itself, and what also the sensor comes with are these little plastic feet that snap into the bottom if they're not already installed, and that is designed to sit on the water heater pan. So as you sit on the water heater pan, to make sure that we don't have any accidental activations and having the metal pan make contact, or a damp concrete floor. So we have some basements out there that have some high humidity, and the concrete floor might be a little cold, and have some accidental activations. There was, when we first introduced this many years ago, I remember reading up on different manufacturers out there, and there was one manufacturer that said, well, take our instruction sheet and put it on the floor and rest the sensor on top of that. So this way you don't have to waste paper. You know, you already have this piece of paper. And I'm like, oh, that's pretty green of the company, and thinking about it that way. And then I stopped and thought about it for a second. When this thing goes off, compared to the day you installed it, might be years, if not decade later. Do you remember how to operate it? Oh, the instructions are right there, soaking wet, where I can't read it. So, yeah, very interesting. I think we try to make it a little bit easier to control and to see what's going on with it. When you are running your sensors, all right, we run them in a daisy chain. So the terminals, you'll see 1 and 2. You want those wires to go 1 and 2 from one to the next. And what you're doing with the sensor looks like the picture you see down at C. Everybody, before the last one, you snap off that last tab. It's just simple snap off of there. You'll see a little perforation on there, and you break it off, and therefore it's looking for that last sensor in the system. So you can do 10 sensors in series with 200 total feet of wire, not 200 here, 200 there, 200 there. It's 200 total feet of wire with 10 sensors. All right, if you need more than 10 sensors on here, that's a lot of hot water. That's a lot of fixtures you have in your home. So, and remember, this is hardwired, not a wireless system that we're looking at there. Excellent. And the last but not least, what we added to the leak breaker system was we took the standard leak breaker, and what we did is add our E-Link connectivity to it. So E-Link connectivity is if there is an activation of your valve, if it senses water, it is going to send an email and a text letting you know that there was an activation. Now, it's not an app. So it's not an app where you can control the device and you're going to open and close it or anything like that. No, this is meant for notification. You would not want to be on your phone, you know, sitting at the beach on vacation, and you look at it and you're like, oh, my valve is closed. Well, maybe I should go ahead and hit it back open again without inspecting. Okay, so that we don't do. So you have to go back, you have to go downstairs, you have to inspect and see why there was an activation. All right, then you go ahead and you silence the alarm, dry off the sensor if it happened to be a false activation, and then hit the open button on the controller. But now we have added this E-Link connectivity. And I got a note from my buddy Rick, who said the CV of the valve was 32. Sorry, I was incorrect. I just had a different number in my head. So a 32 CV of the leak breaker valve, meaning flowing 32 gallons a minute through that valve will give you 1 PSI pressure drop, which means I think I saw a question also from Bill. It looks like we have a 3/4 inch valve. So yes, the CV of 32 of this device, very, very high pressure drop, a very, very low pressure drop. So if you happen to have a larger pipe in the home, you know, as your supply, could you put this on 1 inch pipe and still safely satisfy the home's needs? I think you could. I think you could too.
I think you could go up to 1.5 inches probably with that, with the
Yeah.
CV32.
Right, right. Because all our fixtures are low flow anyway, right? You know,
Yeah.
so.
And that CV32, as you said, means at 32 gallons a minute, that valve will impart 1 PSI worth of pressure drop on the fluid, which is kind of a speed bump in the big picture.
Exactly, exactly right. Yep. So again, everything looks the same with the unit itself. As you see the installs here, now I was showing one before that was showing it mounted right on top of the water heater. It all depends upon your plumbing, what type of water heater you have, where you mount the controller, and the valve itself. Okay. Very, very simple, quick, easy. Anybody that's ever lived through any type of water damage in their home understands the value of this device the next time they put a new water heater back in again. All right. And like I said, it's not an app. It's just going to be a message that comes through that you have been detected, that it's detected a leak in the home itself. And you can set up 2 different numbers. You know, you can set up an email to your contractor as a homeowner, and the homeowner itself can get the email. All right. So depending, so you have an email and a text message that can be supplied. So with that being said, I am done. So if there are any other questions out there, please keep them coming in there. Start bringing them in there. And next week, Takeo Tuesday. Again, we switch over to the commercial guys. So Rich and Brett, we're actually in the other room and they're across the hall from me right now. They're going over chiller plant equipment and piping design. So that is next week at the same bat time, same bat channel for our Takeo Tuesday. Again, I do want to say thank you to everybody for joining us for these Takeo Tuesday seminars and webinars that we keep giving every week. It is greatly appreciated that you come and attend. We do know that value, that 1 hour window, that 1 hour of time that you gave us. We greatly appreciate that. We know that's that one thing you can't get back once you give it to somebody. So we do hope it was really worth your time coming and spending some time with us. If you have any suggestions for webinars in the future, please do not hesitate to contact any of us and give us some ideas. John, Rick, and myself, we get together every couple of months and we start planning out the next 6 months of webinars. So if you have anything in mind that you haven't seen from us with our Takeo Tuesdays, please do. If you showed up a little late tonight and today and you want to see what you missed in the beginning, in 23 hours time, you will get an email giving you a link to watch the webinar itself. You'll also get a link to register for next week's webinar itself too. And we do also upload these to our YouTube page and look for the channel under Takeo Tuesdays. So,
and we will also try to make sure we include a link to those diagrams that Rick was talking about, so you can download those.
Yes, definitely. Yep, we will do that. So I am not seeing any questions rolling in at the moment. I will just keep on blabbering while people are hacking away on the keyboard. Did we have any here? Let's see here. Any other questions that came in? Nope, I think we're good. We answered it all. I see that. 200 feet of sensor. All right, Bill, thank you. William, you're welcome. David Nelson, good to see you. Thank you. And wow, John, 2 days in a row.
Right on time. You hit the mark, brother. Good job.
Wow, that is absolutely strange for me.
Don't get cocky.
I know. I usually run 15 minutes over, so I'm glad I got this one done on time today. So I do greatly appreciate everybody coming by. Anything from the gents that joined me today? Any words?
Nope. Thank you all for being with us. We do appreciate it. And we look forward to seeing you again next week and again the week after. So thank you all again for being with us. We do appreciate the gift of your time, and have a fantastic remainder of your Tuesday and or a fantastic remainder of your week.
Thanks, everyone. Catch
Thank
you
you all.
down the road.
See ya.
So long.